Alright, welcome to Physics Meal. Today on Physics Meal we are going to look at calculations in accelerated motion. Remember that Physics Meal is part of Mathematics and Science Meal program. We have a YouTube channel, Mathematics Meal 1, and then we have a Facebook page, Mathematics and Science Meal. There is need for you to subscribe to our YouTube channel and also follow us on Facebook. It's also important that once you see our video, share it with your friends. It will go a long way in helping us and also helping other people to learn mathematics and sciences. We also have a new program we just introduced, that's undergraduate tutorials. So when you visit our YouTube channel, you also see some of the videos for undergraduates. Alright, today we said, like we said earlier on, that we're going to look at calculations in accelerated motion. Now, motion we know is the change in position of a body or an object with reference to what? To time. We have different motion, translational motion, or what you call linear motion. We have rotational motion. We have the oscillatory motion. Then we have random motion. That's motion of bodies in irregular pattern. When bodies move in non-uniform pattern, that body will be undergoing random motion. Now, these motions we look at them in different aspects. We still look at simple harmonic motion, projectile motion, circular motion, and so on. Then for linear motion, we usually talk about the accelerated motion. So today our business is to see how we can carry out calculations in accelerated motion. Now, I believe that you have known the basics of the accelerated motion, the concept of velocity, the concept of acceleration, the concept of displacement, concept of distance, and concept of time, because these are the quantities that we are going to encounter as we do calculations on accelerated motion. So there are points that we need to take note of for us to carry out calculations. So let's begin to carry out calculations in accelerated motion. We take note of the following. One, when a body starts from rest, initial velocity is 0. That is u equals 0. You remember that we use u to represent initial velocity, while we use v to represent the final velocity. So when a body starts from rest, when a body accelerates from rest, when a body moves from rest, the initial velocity of the body is what? 0. Remember, when we talk about a body, maybe a car, maybe a train, and so on and so forth. Once a body moves from rest, the initial velocity is 0. That's u is equal to 0. When a body comes to rest, the final velocity is 0. So when a body now comes to rest, v is equal to 0. That's v is the symbol that we use in representing the final velocity. Now remember that in our study we'll be using velocity and speed interchangeably. So when we see speed, we are still going to take it as velocity. That's the magnitude of the velocity, because at this stage we are not looking at the direction. So we'll just consider only the magnitude. So magnitude of velocity actually we know is speed. So when you still see speed, we'll be using it as the magnitude of the velocity. Okay, so when a body starts from rest, the initial velocity of that body is 0. And when a body comes to rest, when a body stops, the final velocity is what? Is 0. Now, when a body is accelerating, the velocity is increasing. When a body is accelerating, the velocity is increasing. Thus, the final velocity will be greater than the initial velocity. Okay? When a body is accelerating. Okay? During retardation or deceleration, the velocity of a body is decreasing. Therefore, the final velocity will be less than the initial velocity. That's during deceleration or retardation, velocity is decreasing, and in this case the final velocity will be less than the word initial. During acceleration, the final velocity will be greater than the word initial velocity. So another important point, the fifth one, during retardation or deceleration, the acceleration term A in the equations will be assigned a negative sign. So during deceleration or retardation, the acceleration term in the equations of motion will be assigned a negative sign. So whenever in equation we have deceleration or we have retardation, the acceleration term will be assigned a negative sign. All right. Now there are two methods. Having taken note of these points, they are going to be very useful to us when we begin to do calculations. So there are two methods we usually use in carrying out calculations as far as accelerated motion is concerned. So what are the methods? We have the use of equation and graphical methods. So methods of solving problems. So we say there are two methods. So let's give it a heading. Methods of solving problems on accelerated motion. Okay. Okay. Now there are two methods we use. So the two methods used. There are two methods. Two methods used in solving accelerated motion problems. These methods are the use of equations of motion, and the second one is graphical method. So these are the two methods we are going to concentrate on: the use of equations and the graphical method. They are the two methods, and each of them has its own set of rules or procedures that must be taken in order to use that particular method. So quickly, we need to introduce the first method, which is the use of what? Equations of motion. So let's see how we can use the equations of motion. So the use of equations of motion. So there are 4 equations that are usually used whenever we are trying to solve accelerated motion, problems on accelerated motion. We're going to list those equations and define the terms involved. Remember, someone will expect us to just jump straight and start carrying out calculations, but that's not the right thing that we need to do, because we need to lay a foundation. Most of these points that we are raising, when we meet questions, we are going to see their relevance. So let's look at these equations. Excuse me. The equations of motion include V is equal to U plus AT, X is equal to U plus V over 2 times T, X is equal to UT plus AT squared over 2, and then V squared is U squared plus 2AX. Now someone will say, what are all these for? We are going to define the terms, what they stand for. Each of the term, each of the symbol, we're going to define what they stand for. So let's quickly do that before we go on a short break and then return to carry out calculations. So what are the meanings of all these symbols? So let's look at them. In this case, V is equal to final velocity in meters per second. U is initial velocity in meters per second. A is acceleration in meters per second square. T is time in seconds. Time in seconds. In seconds. Then we have X is distance in meters. Okay? So these are the terms used and what they represent. These are the terms used, what they represent. Alright, that's the foundation aspect of this particular topic on accelerated motion, calculations involving accelerated motion. Remember that when you introduce motion, you have to look at the concept of speed and velocity, compare them, look at instantaneous speed, instantaneous velocity, average speed, average velocity. That's the first part of it, but this one is basically on the calculations, and that's why we have to start with the principles involved in the calculations. So we'll go on a short break, and when we return, we are going to start answering questions as far as accelerated motion is concerned. Remember, subscribe to our YouTube channel. After watching each of our videos, share it and also leave a comment for us, and make sure you give our video a thumb up. Just like our videos both on YouTube and also on Facebook. Thank you and God bless you. Remember, we are coming back in the second part of this topic. We are going to concentrate on calculations, but take time to digest this particular meal so that it becomes part of you, because we are going to make use of it in the next meal we are going to take. God bless you.